Lesson 6.6, Solving Systems of Inequalities. Our objective is to graph a system of inequalities to find the solution area. So the standard that is covered here is Algebra 1 5.2. What a system of inequalities is similar to two or more inequalities in a system. You graph and shade them, and then you find the overlapping shaded region. That is all of the solutions to the system. So we have graphed inequalities before, and you know, when you graph and shade for inequalities, half of the graph is in the solution area, and we did test points and all that. Well, we are going to graph two of them together. You shade in the area where they overlap. That is the solution area. So let's look at an example. So when we are graphing y less than mx plus b, first you graph that as y equals mx plus b. So you graph it as the line, but remember, it could be a dashed line or it could be a solid line. If it is just less than or just greater than, it's dashed because the line is not included in the solution. If it's the or equal to, so the extra line, that means you make it the solid line because the line is also part of the solution. Now, you shade above or you shade below. We talked about that before. Any of the thing that is greater or greater than or equal to, you shade above or the greater y values. If it's less than or equal, you shade below or the lesser y values. So let's see if we can get this figured out. And here's what I'm going to recommend while you guys are doing this. When you shade, to begin with, you shade lightly. And then where you find the overlapping area, that you should shade darker. That's indicating that's your solution area. And what that means is any point from that really heavy shaded area, any of those points will satisfy both inequalities. So if you plug their numbers in, it would make both of them true. That's what the solution area means. So let's look at an example. Y less than 2x plus 2 and y greater than or equal to negative x minus 3. So I'm going to start with the first one, and I'm going to make this one in red. So y less than 2x plus 2. Well, I would start out on the y-axis at positive 2. And I look at the slope, it's positive 2, so that means 2 over 1. Rise 2, run 1. Might do a couple of those just to make sure that I've got my line pretty accurate. And I can even fall 2 and go left 1 to make sure that it's pretty accurate. And I'm going to, that line with it being less than, is it dashed or solid? Dashed. So I'm going to go ahead and put a couple more dots in before I forget. I'm going to go ahead and get a few more of those in. And I'm going to make a dashed line. And if it says less than, my shaded area should be down here. Now I'm going to do this as lines, you'll see, and I'll kind of make a grid, and you can kind of tell on here. I can't really shade like you can with the side of your pencil. Okay, the next one I'm going to do in blue, so to kind of distinguish between the two. Y greater than or equal to negative x minus 3. So I start out on negative x. What's my slope? What's my slope? Negative 1 over 1. So fall 1, run 1. Okay, so what what kind of line is it? It says greater than or equal to. What kind of line would that be? Solid or dashed? Solid. So let's make a solid line here. Let me take that back off. And it says greater than or equal to, so that means that you would shade above. Greater than or equal to is the higher y values. And hopefully you can see where my grid is, that's the solution area. So that's where you would make it extra dark. So let me see if I can do this correctly here. It would be, oops, I don't know how that's going to work. I did not mean, I meant to pull up a purplish, but anyway, it's highlighting it. So that's the part that you would fill in extra dark. That is the solution area. So sometimes your solution areas are going to be bigger like that. Sometimes they're going to be really small on the graph that's there. It's where the shading overlaps is your solution area. All right, now finally over here, it tells us that if you have two lines that are parallel and one you shade on this side and the other you shade on this side, where would they overlap? Josh, nowhere. If that happens to you, then your solution area